So today we're going to be talking about section 3.3, and we're going to talk about properties of logarithms. Now, before we get started, there's a couple rules in logarithms that I don't know that I've covered very well, and I want to take a look at them. So the first is this. Anytime I'm taking log base x of 1, that's always equal to the same thing. It's equal to 0. It doesn't matter what it is. And the reason that is because anything to the 0 power always equals 1. So these two are interchangeable, right? We can say that log base x or whatever, log base 7, log base 12, log base 45, doesn't matter. But log base anything of 1 is equal to 0 because anything to the 0 power is equal to 1. Another thing is this. If we have log base x of x to the b power, it's just equal to b. And why is that? It's because if we do our loop rule, we're really saying x to the b power equals x to the b power. Those are equal things, right? So we can actually say that log base x of something, x to the whatever power, is equal to that one thing. And so we can use that as we go forward to help simplify logarithms. Okay, now with that as a base, let's look at some properties of logarithms. So the first property I want to look at is called the product property of logarithms. And it basically says if you have log base x of some two factors, a and b, a times b, we can rewrite it as log base x of a plus log base x of b. So really, if you look right here, we can break up any logarithm of some multiplication problem, and there's a lot of numbers that have factors that we can break them up. We can break them up into log base x of anything. So an example of that would be this guy right here. So log base 2 of 30, or 5 times 6, I can actually write it as log base 2 of 5 plus log base 2 of 6. Kind of interesting. So I break down, 30 is broken up into two factors, 6 and 5, and I can just rewrite them both, right? So what I'm going to do is I'm going to look at an example problem, okay? We're going to look at this one right here. Log base 4 of 3 is approximately this decimal value, and we can use that to find the approximate value of log base 4 of 192. So how do I do that? Well, I see that I have a 3 right here, so that must be important with 192. So what I'm going to do is I'm going to break it down, and I'm going to say 192 is really 3 times what? Well, 192 divided by 3 is actually 3 times 64. Now, you might be wondering why 64 is important or why it's significant. Well, 64 is actually a power of 4, right? And so what is that? So if you ever want to figure this out, what you're going to do is you're going to take 64 divided by 4, and you get 16, which divided by 4 is 4 again. So really 64, another way to write that would be 4 to the third power. So our factors that we have of log base 4 of 192, our factors of 192 are going to be 3 and 4 to the third power. So I'm going to rewrite it as that. So log base 4 of 192 is really log base 4 of 3 times log base 4 to the third. Now, we just said with our product that we can actually write this now as a problem using addition. So we're going to do that. We're going to say that this is really log base 4 of 3 plus log base 4 of 4 to the third power. Now, knowing what we just said at the beginning of the video, log base 4 of 4 to the third is really just 3, right? Because the log base 4 and the 4 cancel each other out. And we know that log base 4 of 3 is that decimal 0.7925. And so when we add them, we find out that log base 4 of 192, 0.97925 plus 3, is going to be 3.7925. Okay, so we figured it out. That's our approximate value. Now, thinking forward, how do you think you could check your answer? Well, what you could do is you would say, okay, so looking at the original problem, log base 4 of 192 is approximately 3.7925. So using the loop rule, okay, so I'll rewrite it down here. It says log base 4 of 192 is equal to 3.7925. So using our loop rule, we should really say that 4 to the 3.7925 power should equal 192. So let's do that. 4 to the 3.7925 power is equal to what? So we check that on our calculator. So I go to my calculator and I do 4 to the power of 3.7925 and I get 192.004. So it's really, really close to 192. So we know for sure that 3.7925 is the correct approximation for log base 4 of 192. Okay. Now, we said that in the last one that anytime you were multiplying two factors or you had the log of two factors, we could add them. Now we're talking about quotients or division. So anytime we have log base x of a divided by b, it can actually be written as a subtraction problem. And so here's an example right there. Log base 2 of 5/6 can really be written as log base 2 of 5 minus log base 2 of 6. And again, this is really nice because we don't have to worry about fractions anymore. It can just be a subtraction problem. Okay, well, let's look at an example. Now, this is a real world example, but it can be done with regular numbers as well, not just missing values, right? So let's take a look at one. It says the pH of a substance is defined as the concentration of hydrogen ions, H plus, in moles. If given the formula pH is equal to log base 10 of 1 over H plus, find the amount of hydrogen in a liter of acid that contains a pH of 4.2. So really they're saying, okay, well, what is, if I let my pH be 4.2, so 4.2 is equal to log base 10 of 1 over H plus, okay? Well, according to our product rule, it really says that we can rewrite this 4.2 as log base 10 of 1 minus log base 10 of H plus, okay? So thinking about that, we just said at the beginning of the video that log base anything of 1 is really just 0, right? So that actually just becomes 0 because 10 to the 0 equals 1. And so now I'm left with really this problem. This is what I have. I have 4.2 is equal to negative log base 10 of H positive. Now, how could I solve that? Well, according to the loop rule, right, if we're looking for this, it's really going to be equal to 10 to the 4.2 is equal to that. And it's negative, so we'll just let that be negative 4.2 to off base it. And so we'll say 10 to the negative 4.2 is equal to H positive. Okay, so go to our calculator. We do 10 to the power of negative 4.2, and we find that H positive, okay, or the amount of hydrogen ions is going to be 6.5 times, or excuse me, 6.3 times 10 to the negative 5 moles, which you would know from a chemistry class or something like that, that's a reasonable size for hydrogen atoms, okay? All right.